Здрасте, здрасте, добро пожаловать в очередной эфир по... Нет, подождите, как говорил классик, здрасте, здрасте всем. Добро пожаловать в очередной эфир по SwiftUI. Надеюсь, часика 3-4 позаниматься этим. И потом посмотрим, куда буду двигаться дальше. В прошлый раз закончил день 50. Секундочку, мне надо ссылку проверить. День 67. Сейчас начинаю с дня 68. Ну, пишу тайм-коды, погнали. Только на правильной клавиатуре надо писать. Полетели. День 68. Вам будет приятно узнать, что у вас сегодня самый легкий день за долгое время. Это не значит, что мы рассматриваем неважные вещи. Просто новые методы, которые мы освещаем, гарантированно станут желанным перерывом в Core Image. Все, что я могу, это... Наслаждайтесь, пока есть время. Завтра мы снова займемся сложными делами, так что я не надеюсь, что это сюрпризом. Уже перевалили за 2/3 за эти 100 дней. Продолжайте в том же духе. Единственное место, где успех предшествует работе, это словарь. Ну, в русском языке это не подходит, а в английском... вы где? ОПР. СТ, да, сначала работа, потом успех. Да, тоже подходит. Угу. Окей, сегодня что мы будем применять? Comparable, точнее, имплементировать. Comparable, искать директорию пользовательских документов и так далее. Давайте почитаем, что у нас тут есть. Итак, введение в новый проект Bucket List. Bucket List Introduction. В этом проекте мы будем делать приложение, которое позволяет пользователям составлять приватный список мест на карте, которые они собираются однажды посетить. И добавлять описание этому месту, смотреть интересные места поблизости и сохранять это все в iOS Storage на потом. Чтобы это работало, чтобы это все заработало, вам придется задействовать некоторые навыки, с которыми вы уже знакомы, таким как формы, таблицы, не таблица, а sheets, codable, URL session, но также выучить новые скиллы, навыки, как подключать карту в SwiftUI приложение, как сохранять приватные данные безопасно, чтобы только аутентифицированный пользователь мог иметь к ним доступ, как загружать и сохранять данные извне user defaults, или как это, outside of user defaults, за пределами user defaults, окей. И так далее. Много чего выучить. Еще одно отличное приложение. В любом случае, давайте начинать с нашими техниками. Создайте новый проект, используя этот bucket list, используя шаблон для приложения и назовите его bucket list. Но это у меня уже вроде бы есть. Сейчас я его открою вместо того, чтобы создавать. Так, это файл close project, stop tasks. Так, stop tasks. И теперь Open Existing Project. Открыть уже существующий проект. Так, мне нравится, как картинка здесь выглядит. Ну да ладно. Так, bucket list называется, да? Bucket list. Есть такой пассажир. Их есть у меня. Окей, это готово. Идем дальше. Следующее это adding conformance to comparable for custom types. Давайте посмотрим.
When you think about it, we take a heck of a lot of stuff for granted when we work with Swift code. For example, if we were to write 4 is less than 5, we expect that to return true because the developers of Swift and LLVM, the sort of larger compiler project that sits around Swift, they've already done all the hard work of making sure that calculation is actually true for us. So we haven't got to worry about it. But what Swift does really well is extend functionality into lots of places using protocols and protocol extensions. For example, we know that 4 is less than 5. We know it's true, okay? Because we can compare two integers, 4 and 5, and decide does this one here come before this one here. 4 comes before 5 in the numerical sequence, okay? Swift then extends that functionality to arrays of integers. We can compare all the integers in an array to decide whether one should come before or after another. And then Swift uses that array and that sorting to just get the whole array sorted. So in Swift, we expect to be able to say there's an array of numbers like let values is 1, 5, 3, 6, 2, 9, for example, and then make a little loop here of all those values with ID of self because they're all unique. I'll do a text string of that number like so. And when that code builds, with a capital S in string obviously, when that code builds, we should see a simple list of 1, 3, 5, 6, 2, 9, like that, boom. But we expect to be able to say, actually, you know, I typed those numbers in the wrong order, just sort them for me. And that code, when it runs, boom, 1 through 9 all appear correctly. We don't have to tell sorted how it works. It understands how arrays of integers work, how they should be sorted. Now consider a struct, like this one. There is a struct called user that conforms to the identifiable protocol. This has an ID, UUID, then a first name, string, and a last name, string. So we can go ahead and make an array of these users. Let's just delete this code here for temporarily. We'll say our user array contains a user with the first name of Arnold, last name Rimmer, then a user, first name Christine, last name Kochansky. And let's do one more. User first name David, ID, last name Lister. And they conform to identifiable already, so I can just write in here, go over all the users, no ID anymore because it conforms to identifiable. And I'll just write the text of, let's do user.lastname, comma, user.firstname, like that. Oops, daisy, this uses user in. There we are, so I'm missing, boom. When that runs, we're going to see Rimmer Arnold, Kochansky Christine, Lister David. And that works just fine because the user struct conforms to identifiable. But what if we want to show all these users here in a sorted order? If we said, okay, we've seen how sorting arrays works, I'm going to try calling sorted on users, that code won't build. Swift does not understand what sorted means here. It doesn't understand, do you mean by first name, by last name, by first name and last name, by ID, or something else? Now, one way of doing this is to provide a closure or function to this sorted call here to do the sorting ourselves. This will hand us two objects from the array, $0 and $1 if using the shorthand names here. And we've got to return true if the first object, $0, should come before the second object, $1. And so we could say sorted based on does the first last name come before the second last name, like that. And that's valid. So it's now Kochanski, Lister, Rimmer. KLR, which makes sense. And that code works. It's fine. But it's not an ideal solution for two reasons. First, this, how we sort information, I consider to be model data. By which I mean it's affecting the way we actually work with the user struct. Now this struct and all its properties are our app's data model. And in a well-developed application, we don't really want to tell the model how it should behave inside our SwiftUI code. SwiftUI represents our view, our layout here. And if we put our model code in there, trying to sort stuff down here, then the things just get confused. Second, what happens if you want to try and sort user arrays in multiple places? Well, you can just copy and paste sorted code again and again and again. Sort last name less than last name again and again and again. But then you realize you're just making a problem for yourself. If you end up changing the way your sorting logic works, perhaps you sort by first name, then last name, or last name, then first name, whatever, then you've got to try and search through all the code to make sure all these sorted calls get updated at the same time. Swift has a better solution for us. Arrays of integers get a simple sorted method because it understands already how to sort two integers. We're going to provide this closure every single time. In coding terms, int, that object inside the array, conforms to the comparable protocol, which means it defines a function that takes two integers and returns true if the first comes for second. This thing right here. Now we can make our own types conform to comparable, and when we do so, we'll also get that same sorted method with no parameters. This takes two steps. I want to add the comparable protocol to the
Про протокол comparable. А мы здесь работали с протоколом equatable. Где правда? Comparable тоже есть. Окей.
definition of our user type, and then add a method called less than, just like angle bracket less than, which takes two users and returns true if one comes for the other. So we'd say here, you are now comparable and identifiable. And inside here is a new method, static func less than, as angle bracket. Left-hand side object will be a user. Right-hand side object will be another user. And it will turn bool if the left-hand side comes for the right-hand side, which for us is simply LHS.lastName is less than RHS.lastName. The same check down here, just now with names left-hand side and right-hand side. That's there because we always write user A less than user B. One's on the left, one's on the right. There's not a lot going on there. It's quite small, but there's still a lot to unpack. First, yes, this method is just called less than. Okay, it's the job of this method here to decide whether one user is less than, i.e., in a sorting sense, less than another user. Comparing these two right here. So adding functionality to an existing operator. Less than is already used to compare integers or strings or dates, and now it's used for comparing users. This is called operator overloading, and it can be both a blessing and a curse. Second, again, the LHS and RHS are coding conventions, short for left-hand side and right-hand side. And they exist because the less than operator has something on the left and something on the right. Now you can see this method here returns a Boolean. Okay, this means we must decide whether this user comes for this user or the other way around. There is no room for they are the same. Okay, that's handled by another protocol called equatable. It cannot be equal to something else. Fourth, this method is marked static, which means it's called on the user struct directly. Right, user.less than one side and other side like this, rather than making an instance of a user struct first and calling it on that. And finally, our logic here is really simple. We're just passing on the comparison to one of our properties inside the struct, asking in this case Swift to use less than on the last name string of both our objects. You can of course add as much logic here as you want, but ultimately you must return true or false. Now, one thing you can't see in this code is that conforming to comparable, you can see we have this whole less than working here just fine, but it also gives us access to greater than, like that. That also now works for user instances. This is the opposite of less than. So internally, Swift just creates it by using less than, then flipping the results, which makes sense. So now our user struct conforms to both comparable and identifiable. We can go ahead and use the built-in sorted method like that, and it will work. Code still runs great. This resolves the problems we had before. We now isolate all our model functionality right here inside our user. And we no longer have to copy and paste that sorting code around. We just call sorted directly everywhere. Safe in the knowledge, if we ever change the algorithm for sorting, this one right here, all our code will adapt.
Окей. Ничего нового. Идем дальше. Writing. Writing data, да. Следующий раздел, следующий пункт из этого дня — это writing data to the documents directory.
Previously, we looked at how to save and load data using user defaults, which is great for small amounts of data or even small amounts of JSON if you need to. We've also looked at Swift data, which is great when you want to have relationships between objects or more advanced sorting and filtering. In this app, we're going to look at a middle ground, just storing our data in a file directly. This is not because I somehow hate Swift data, and in fact, I think here Swift data would be a very good choice indeed. Instead, my goal here is simply to show you the full spread of what's possible in iOS development. And you'll see lots of apps out there that work exactly like this app will do, writing data to and from files. It's good to at least see how that approach works. That being said, user default is definitely the wrong choice here, okay? In our app here, we're going to let users create data over time, so there's no limit to how much data they can add to the app. And user default is not good for that. Simple settings and similar. Swift data maybe, but not user default here. Fortunately, iOS makes it easy to read and write data from device storage, and in fact, all apps get a directory for storing any kind of documents we want to have. Files, in this place, our documents directory, are automatically synchronized with iCloud. So if the user gets a new device through, then our data will be restored along with other system data. We won't even think about it. There is a small catch though, and there always is, right? It's that iOS apps are sandboxed. They run in their own little container, which is in a hard to guess directory name, so you can't poke around and find other things easily. They're all carefully locked down. So as a result, we can't, and we shouldn't try to, guess the directory our app is installed. Instead, we're going to rely on a special URL called url.documents directory. For example, here if I had func test, I'd something like this, print url.documents directory. This directory here is ours to do with as we please. And because it belongs to our app, it'll automatically be deleted if the app is deleted. Other than basic device limitations like how much storage the user has, there is no limit to how much data we can store inside here. But do remember, users can go to the settings app and see exactly how much storage your app is using. So try and be careful, be respectful. So that's our directory we can work with. Once we have that, we can read and write files in there previously. We've seen string contents of and data content of for reading and writing data. But for writing data, we need a different method called write to. This takes two parameters. Firstly, a URL to write to, and then any additional options to use when we're doing our saving. The first of that, the place to write to, is combining our documents directory path here with some kind of file name, for example, myfile.txt. As for the second, I prefer to give this thing two values as an array. One is atomic, and one is complete file protection. They do very different things, but both are important. Atomic means we are asking the file to be written inside one lump. Now, this is not included, and we try and write a big file out, okay? It's possible another part of our app might come in and try and read the file while it's still being written. Perhaps only half the file's there at this point, and it reads now halfway through the write operation. This won't or shouldn't cause a crash or whatever, but it does mean it'll only read part of the data because the other part hasn't finished being written yet. Atomic writing tells the system, please write the full file out to a temporary file somewhere else, so it fully exists on disk. And when that's done, rename to the correct location. So it's basically an instant write operation, so it avoids that middle writing problem. Asking for complete file protection means iOS automatically and transparency encrypts our file and means the app can only read it while the device is unlocked. Now, iOS does a great job of keeping user data secure by default, but there's no harm being extra safe. Okay, let's put this into action. We're going to modify this default sort of VStack thing going here. So it writes a test string to a file and reads it back into a new string and prints it out. So you can see the complete cycle of reading and writing data. So let's get rid of this testing here. And instead say in our body, we have a button saying read and write, like that. And the first thing we'll do is have some data to write. So I'll say our data is the data of the string test message.utf8. So that means get the string encoding, UTF-8 encoding of this message and convert it to pure data. We can now decide where to save it. Our URL will be url.documents directory, appending the path of message.txt. That becomes the exact place we want to write that data to. Now start do block, because it might throw errors. We'll try calling our data write to that URL. And for options, I'm going to ask for atomic and complete file protection. Stash those both things away safely. And then let's catch an error first so it's happy. Print error.localize description, that's fine. Once it's written out, I'm going to get our input back again by calling try string contents of that same URL. Read it back into a string and then print the resulting input like that. So I'll press Command R now, give it a quick try. We should see our little button hopefully on the screen in a second, and pressing it should print test message out down in our console down here. Boom. So that's reading and now writing safely as well. Before we move on, there's one small challenge I want to give you. Back in Project 8, we looked at how to make a generic extension on the built-in bundle type that lets us find, load, and decode any kind of codable data from our app bundle. Can you write something similar for the documents directory, perhaps making an extension on File Manager?
Так, у меня уже такое есть. Extension для файл менеджера. Static var documents directory, двоеточие URL и внутри тела. Замыкание let pass равно file manager .default.urls for .document directory in user domain mask. Return pass 0. Так, следующий. Спрашивают не за Q. Английскую речь на слух легко понимать? Да, абсолютно. И английскую, и американскую, и британскую. А тебе? Так, следующий ролик насчет переключения состояния state с помощью enums. В том числе я по-английски это слушаю, чтобы и улучшать способность понимать английский. Хотя здесь я понимаю все. Ну, в том числе потому, что я уже это один раз прослушивал.
You've seen how we can use regular Swift conditions to present either one type of view or another, like this. We could say, if bool.random, let's do a rectangle. Otherwise, let's make a circle, like that. And it'll change randomly as the view runs. Now, as a reminder, this kind of logic can only go inside a body property directly, or a property using the view builder attribute or group. Now, where conditional views are particularly useful is when we want to show one of several different view states. Hello, dogs. If we plan it correctly, we can actually keep our view code nice and small and also fairly easy to maintain. It's a great way to try and start training your brain to think about SwiftUI architecture and how it looks good. Now, there are two parts to this kind of code. First, you want to define enum for the various states you want to represent. For example, we might say there's a nested enum here in content view. I'll say it's called enum loading state. It'll have a case for loading, a case for success, and a case of failed. And next, we can make individual views to represent each one of those states. Now, I'm going to use just simple text views here, but they could hold anything in practice, like some hungry dog pictures, for example. So we might say, for example, I want to have a
Я не настолько хорош. Получится, что я буду одновременно решать в голове две задачи. Одна по переводу языка разговорного, а вторая по пониманию языка программирования. Что будет мешать друг другу? А ты тоже сейчас этот курс изучаешь или как? Потому что поначалу мне тоже было, я вот тоже с субтитрами смотрел, и я не скажу, что мне было тяжело. Отдельные какие-то слова были непонятными, именно термины. Вот, а так нормально. Смотря где ты находишься, смотря как и что. Я вообще начинал переводить этот курс, но не закончил это дело. А так, я думаю, что это было бы достаточно полезным для тех, кто по-английски не говорит, для русскоязычных разработчиков, студентов, учеников и так далее. Перевод языка разговорного. Ну, смотри, если у тебя какой-то есть базовый английский, то так, и сейчас же есть закадровый перевод на лету любого видео онлайн. Есть в Яндекс браузере, по-моему, такая штука работает. Но я в этом не нуждаюсь. Более того, я вот что скажу. Когда я для себя открыл англоязычный интернет, англоязычные ресурсы, да, именно по обучению, у меня открылся дивный новый мир. То есть у меня расширилась база знаний, вот, из которой я могу черпать ресурсы. И, ну, я скажу так, что после того, как я с этой базой знаний ознакомился, и вообще то, как подается информация, само количество информации гораздо больше, то я не особо меня тянет обратно. Я могу что-то там загуглить, но мои запросы, они уже англоязычные, много информации и так далее. Ну и сама подача, она более логичная, более структурированная, последовательная и так далее. Так что, ну, я бы не рекомендовал, ну, опять же, решать мое личное мнение, я для себя смотрю на английском языке. Мне так больше нравится, мне так понятнее. Я пытался включить какое-то обучающее видео по SwiftUI или по другим вещам на русском языке, и мне уже сложно слушать подачу на русском языке. Ну, как есть. А у тебя какой же опыт в программировании? Ну, да, сложно так сказать. В программировании я уже давно. Вот, а коммерческого такого прям именно на компанию работать у меня немного опыта. Я писал на питоне. Там одни такие с железками, короче, работал. На питоне писал. А так остальное все это проектная работа. Там и питон, и iOS-разработка. У меня есть там приложение опубликованное. Ну, так. iOS-разработкой я занимаюсь на данный момент. Вот, ну, плотно изучаю. Наверное, пару лет.
Struct called loading view. That is a view, and its body property is going to say the word loading, like that. Then I'll do another one called success, struct even success view. This is also a view,
На
and
самом
there
деле,
we'll do
мне так сейчас немного неинтересно этот урок слушать, потому что я его уже слушал. Да не в этом даже дело. Я вот то, что он говорит, я все это понимаю, я это очень часто делаю. Например, переключение текстовых полей, да, на каком поле фокус. Это фокус state, и в него я могу передавать enum как раз.
text of
Ну ладно,
success.
я просто ускорю
And we'll do
немножко.
one more down here, which
Если будет проще, я как раз сюда специально вывожу субтитры.
is struct failed view. Again, a view that'll do text of failed. So nothing fancy here, just to show moving between these various views. Now, these views, they could also be nested. They could be inside the main content view, but they don't have to be. It really depends on whether you plan to use these views elsewhere and the kind of size of the app you're building. Now, these two parts in place. One set was the
Если еще не подписаны на мой Twitch, и также у меня есть YouTube канал, то можете подписаться, буду благодарен, чтобы не пропускать, потому что я каждый день в эфире по JavaScript, и также сейчас, скорее всего, буду каждый день по Swift. Возможно, не каждый, вторники, четверги у меня под вопросом, а так каждый день. Так что будем поддерживать друг друга в обучении и дальше в программировании и в развитии. Так что подписывайтесь. Добро пожаловать.
enum working with them, other sets of views to show, we can now effectively use content view as a simple wrapper that tracks the current app state and shows the relevant child view inside it. This means giving it a property to store that current loading state. So I'd say like at state, private var, loading state is state with A in it. is loading state.loading, like that. And now we can go ahead and fill the body property in with code that shows the correct view depending on the enum's value. So we might say here, if loading state is equal to loading, then do loading view. Otherwise, if loading state is equal to success, do success view. Otherwise, if loading state is equal to failed, do failed view, like that. If you want to, you have a switch case instead. You might have said, for example, switch loading state like that. And then for our loading view here, success view here, or failed view here. Enums do have the advantage that they are checked to be exhaustive. If you add a future case in the future, I don't know, case unknown, for example, you have to add a match for it here inside the enum switch here. Otherwise, it wouldn't work. Whereas if, else if, wouldn't get that tool. So using this approach, our content view's size doesn't spiral out of control as more and more code added to it. And in fact, it doesn't even know what loading view, success view, or failure views even look like.
Да, это мы уже знали. Таким образом, день 68 я просто отмечу, что он пройден. А какой у тебя опыт программирования? Вообще, в каком ты сейчас состоянии на эту тему? 60. Challenge. Видимо, тут было что-то другое. Окей. Переходим к дню 69, получается, да? Так, у меня есть небольшой опыт на C-Sharp, тоже пару лет, но давно. И сейчас я смотрю на новые возможности, которые открываются для программистов с приходом ИИ. Какого рода возможности? Какие-то новые направления или вообще не связанные с таким программированием, типа какой-нибудь ноу-код или инженер промптов для этого? Так, 38. Ну, так, поражает, что и чат-модели в первую очередь полностью автоматизируют работу именно программистов. Эту революцию не заметить невозможно. Есть определенная настороженность у многих людей, но я бы не преувеличивал его значение. Типа полностью автоматизация и так далее, и так далее. Все равно еще так, то, что можно писать код, решать проблемы с помощью ИИ. Это да, но главное не поддаваться паническим настроениям, что ИИ всех нас заменит, всех программистов, всех на свете и так далее. Кого-то заменит, кого-то не заменит. В любом случае, до этого еще, я думаю, не то чтобы далеко, не знаю, вообще дойдет или нет, несмотря на действительно впечатляющие вещи, которые он делает. Но в конечном счете, на данный момент, чтобы сделать что-то серьезное, и то есть с нуля он систему не напишет, все равно нужен человек, который совместит какие-то части, что-то уточнит, что-то подправит. То есть все равно специалисты нужны, так что так. Так. Следующий день, начинаем день 69, проект 14, часть 2. Смотрим, что он нам здесь принесет. Во второй части обзора методик для этого проекта мы рассмотрим два важных фреймворка для iOS, MapKit для рендеринга карт и Local Authenticator для использования Touch ID и Face ID. Вас не удивит, что местоположение, отпечатки пальцев и распознавание лиц действительно являются личными для пользователя. Это значит, что мы должны относиться к местоположению в любое время. Пользователи доверяют нам обращаться с их данными с максимальной заботой и намерением в любое время. Поэтому хорошо бы настроиться на то, что конфиденциальность, безопасность и доверие являются вашими основными ценностями, а не дополнительными опциями. Ценности, как отпечатки пальцев. Все люди разные, но выставляйте их на всех вещах, к которым прикасаетесь. Проект находится в центре диаграммы Вены, как ценностей, так и отпечатков пальцев, так что будьте внимательны, это важно. Две темы. Как встраивать карты в приложение SwiftUI и как использовать Face ID для разблокировки приложения и многое другое. Окей. Полетели потихонечку. Итак, первая часть этого дня – это интегрирование MapKit в SwiftUI.
Maps have been a core feature of iPhone since the very first device shipped back in 2007.
У разных программистов производительность может отличаться во много раз, но с помощью ИИ можно повысить ее в разы. И те, кто не будет использовать теперь разработку, не смогут конкурировать. Это как копать лопатой или экскаватором. Ну, часть правды в этом есть, потому что он позволяет оптимизировать вещи, он позволяет быстрее что-то делать и так далее, и так далее. Вот. Ну, это как инструмент, то есть сам по себе он не работает. Нужен все равно кто-то, кто будет его использовать. Вот, и уже как ты его используешь, это уже другой разговор. Но вообще это отдельная тема, большая, важная. Вот, как-нибудь поговорим на нее.
And the underlying framework has been available to us developers to use for almost as long. Even better, Apple provides a SwiftUI map view that wraps the underlying map framework beautifully, letting us place maps, annotations, and more right alongside the rest of your UI view hierarchy you have already. Let's start with something real simple, just showing a map on the screen. Maps and all their configuration data come from a dedicated framework called MapKit. So our first step is to import MapKit to our file. And now we can place a map in our SwiftUI view with just one line of code. Map, like that. There's the map, okay? That's enough to show a map on the screen. Do press Command R, try noodling around a little bit. You'll find you can drag around a little bit and so forth. I would, if I were you, take a moment to learn the various shortcuts you can have here. For example, if you hold down the Option key, like that, you'll see two fingers appear. And if you click and drag, you can do pinch gestures like that to zoom in and out, and they move close together nicely. If you hold down Option and then Shift, they stick together like that. And now you can just a tilt of the thing, the pitch, to get different angles like that. And if you want, you can simulate the single finger map gestures you have on iPhone by just clicking once, clicking again, and dragging up and down with your mouse. So again, that's click once, click again, and drag up and down, just like you can have on the regular Maps app. Now, once you're in control of the app here, feeling good, there are stacks of ways you can customize this basic map view. For example, you can add a map style modifier to customize how the map views. We could say, I like a map style using dot imagery. Give me a satellite style map like that. Or we could say I want to have the satellite view, but also street map data. That's called a hybrid map. And they get place names and roads and similar. Or you could say I want to have both maps, so satellite and street information, hybrid map, but I want to add realistic elevation, making a 3D map. So say hybrid with elevation option of dot realistic. And now I press Command R, just explore the map a little bit. You could say, okay, let's go down here into London. Obviously, not the whole world has realistic elevation. That'd be a bit much. You can just basically zoom in and find a place. Here's Trafalgar Square. Here's Westminster Abbey and stuff down here. And it's got 3D mode turned on. So when you do your whole pitch option, which again is Option and Shift like that, and go in, you'll see it's all in 3D mode now. So you can just basically grab this thing and try zooming around, in this case, the Tower of Westminster right here with the Big Ben inside. So you can see it's all very nice with basically almost no code. If you want to adjust the way the user can work with your map, like can they zoom or rotate or whatever. For example, we can make a map that always stays centered on a particular location, but users can still adjust rotation and zoom. We could say this map has interaction modes of, let's do rotate and zoom. And so now I can go in and out, I can turn around and around, but I can't go up and down. I can basically only go in and then around that area. I can't, zoom in on it. I can't pan around anywhere. Or we could say, actually, there are no interaction modes. An empty array here, meaning the map is always exactly fixed. You can't pan around, you can't zoom, you can't rotate, nothing works anymore. Now, those are all the easy customization options, but there are some more that take thinking. Firstly, controlling the position. Second, placing annotations. And thirdly, handling taps on there. First, you can customize the position of the camera either as an initial position where you're saying where the map should start, or as a binding to its current position which tracks it over time. For example, I could say, let's add a property to our view here, storing the location of London. So let's take a bit of code, I'm afraid. Our position is a map camera position dot region, like that. This takes, you can see, an MK coordinate region, and that's where the code comes in. They're pretty wordy. MK coordinate region here. You can see it has a center and a span, as in what to focus on and how much to show around it. So we'll say that our center is CL location coordinate 2D, and you'll provide latitude and longitude here for where you want to focus the thing on. Our latitude of London is 51.507222, like that, and the longitude is minus 0.1275, that. And the span is how much to show around it in the degrees of the latitude and longitude. They are complex. If you're into maps, you'll know that the size of the span varies on where you are in the world. As you're going north and south, they stay the same. It's like 111 kilometers, I think, per degree or something like that. And the going east to west, they shrink as you're getting very close to the pole. So if you're getting near the top, you're going to walk very, very far around the entire world. Whereas at the equator, it matches, I think, 111, 116-ish, something like that. So a bright span. I'm going to say on MK coordinate span, latitude delta of 1, longitude delta of 1, like that. And that'll give us a decent view of London. Actually, I'm very sure it might even say the size of these things in the documentation if we're lucky. Not there, cool. This one, or there, cool. So the Apple, I'm sure, somewhere say the size of these things, but clearly not where I'm seeing it here. There we go. 111 kilometers, boom. So at the equator, 1 degree of longitude is 111 kilometers, but at the poles, it's 0 kilometers because obviously it's tiny, infinitely small at that point. Anyway, that is London as a position, and I can use that for the starting position for our map. So I might say here that the initial position is that position value. And now when the map's previewed like so, hopefully, boom, we see London neatly framed on the screen. Now this specifies an initial position. If you want to change the position over time, you're going to mark it as state, then pass in as a binding. So we'd say here, at state, private var position, like that, same otherwise. And then for the map down here, we'll pass in position as, with P, as dollar position, like that. So it's a two-way binding. It's not going to work the way you expect. That's okay. I'll explain in a minute why not. But now that it's program state, we can change it by adding some various locations with buttons around the map to jump to. For example, we could place this whole thing inside like a VStack with the map inside it. And after the map, add a HStack with, let's do spacing 50. And then we'll do a button called Paris, like that. There we go. And when that's pressed, position set to a map camera region. Get rid of the big code again. MK coordinate region. We've got that one. So center for Paris. Oops, Daisy. It's going to be a CL location coordinate 2D, latitude of 48.8566, and longitude of 2.3522. And then for the span, 1 and 1 is fine. So that's MK coordinate span, 1 and 1. So about the same zoom level as London. Then we'll add some more. Let's do, that's Paris. We can do another one for maybe Tokyo below it. Add more if you want to. I'm not doing any more than that. You get the point. Tokyo is here. And for Tokyo, our position is going to be centered at 35.6897. And then longitude of 139.6922. Same approximately zoom level, like that. So I'll press Command R and see how it looks. It should now jump between various well-known capitals. There's London, there is Paris, and there is Tokyo. Always surprises me that London's actually surprisingly big in terms of its sprawl compared to Tokyo. Because there's nothing. This is basically Fuji almost at this point in Tokyo. Anyway, they build higher than we do. Okay, so like I said, although we're passing a binding to the map, this thing here, the two-way binding position, we can't just read the new position value as the user moves around. Instead, we've got a separate on-map camera change modifier that tells us when the value changes either immediately or once movement has ended. For example, we could say, I want to get an update when the map's finished being dragged and print out the new location. So I'd say here, on map camera change, print, actually I'll accept the context, sorry, the map update context here, print context.region, like that. What is being shown? What that means is now I can basically drag the map around fully. Let's clear the log a little bit. Drag it around. Nothing's printed out. When I release, it finally prints out. So it's only doing it when you actually stop dragging. And there's your new data. If you wanted continuous mode information, you could ask for that. Just add frequency of .continuous, like so. And now you'll get updates constantly as you're dragging. So now if I clear the log out, here you're going to see it's just constantly printing out data. I'm going to release to get the information. Now, you might think continuous mode is always preferable, but it's really not that simple. If you're running a search on where the user has placed the map, for example, that's the kind of thing you only want to do when they've actually finished moving, not constantly. There's no point. The second customization I want to look at is how we place annotations. To do this takes at least 3 steps depending on your goal. You want to define a new type that contains your location information. Then you want to make an array of all those locations in one place and then add them as annotations in the map somehow. Whatever type you choose to work with must conform to identifiable, so SwiftUI can know each map location uniquely. For example, we might start with a new struct called location, which is identifiable, has an ID attached to it, and then a name string and a coordinate, CL location coordinate 2D. And now we can basically go ahead and define a range of locations in our body here. I could say, for example, locations, type it in, locations is an array of, I'm going to do just like 2 of these things. Location, name is Buckingham Palace, coordinate is CL location coordinate 2D, 51.501, longitude minus 0.141. And then second one will be Tower of London, coordinate for that is 51.508, longitude minus 0.076, 766, right? And now step 3 is the important part. Let's get rid of some code here, it's not used anymore. You can just go away. You can just go away. Oh no, location still. Sorry, no, location. Sorry, I'm being silly. Leave it there. Go away. Fine. Now, the important part. We can feed the array of our locations into the map view as content display. Now, SwiftUI provides a couple of different content types to display, but a simple one just called a marker. A little balloon on the map with a title and a latitude, longitude, coordinate attached to it. For example, we could say this map has something inside. We'll do a for each our locations with one location coming in. And we'll use that to say there's a marker of location name with a coordinate being location's coordinate, like that. And when that code runs, you're going to see 2 balloons appear on our map, one at Buckingham Palace and one at Tower of London. And also notice, by the way, how the map has automatically zoomed in to make sure those 2 markers are fully visible. Now, if you want more control over your markers, you want to use a different type, not just marker. You want to use one called annotation. This lets you provide a completely custom view to use instead of the standard sort of balloon thing they have going on. And if you prefer, you can also hide the default title and replace it with your own. For example, we could say there's an annotation with those information, but then inside that will be the text of our location name in a font of headline with some padding around it, then a background of blue gradient, then a foreground style of white, and a clip shape of capsule. I'll also say that we have an annotation titles of hidden, hide the default marker for it. Now it should see our things visible like so. Very nice. As a second way to customize it, the last one to look at is how we handle taps using an on-tap gesture. This tells us where on the map the user tapped, but it does so in coordinates relative to the whole screen, how many units to the right and down we have on our screen. What we want to look at the actual map location all the time. Where did they tap? They've tapped on Clapham, for example, or Chelsea or whatever. That's where they tapped on that exact coordinate. To do that, we need a special view called a map reader. And when you wrap one of these around a map, you'll be handed a special map proxy object that's able to convert screen locations to map locations and the other way as well. So we'd say in our code, around our map is a map reader with that proxy coming in. In the code inside it like so. And now, let's just ditch all the for each, not needed anymore. Now, we'll add an on-tap gesture with the screen position coming in. And we'll say, can we convert that screen position to be coordinates? We'll say, if let our coordinate is our map proxy, converting that point on the screen position from a local coordinate space, then print the coordinate out. Now this local part, this means we're converting the map's local coordinate space for this position, meaning that if you have a a big layout with just your map being a tiny part of it, it's measuring from the top left corner of just the map by itself. If you had said, give me in global space, it goes to the very root of the whole screen rather than the root of where the map actually is.
Не совсем понятно было.
On map proxy, converting and print the coordinate out. Meaning that if you have this means we're converting the map's local coordinate space for this position. Meaning that if you have a big layout with just your map being a tiny part of it, it's measuring from the top left corner of just the map by itself. If you had said, give me in global space, it goes to the very root of the whole screen rather than the root of where the map actually is.
Окей. И вторая тема в этом дне. Давайте запишем. Это использование Touch ID для и Face ID вместе со SwiftUI.
The vast majority of Apple's devices come with biometric authentication as standard. That means they use fingerprint, facial, and even iris recognition in the Vision Pro to unlock. This functionality is available to us too, which means we can make sure our sensitive data can only be read when unlocked by a valid user. This is, sadly, a really strongly powerful Objective-C API, but it's only a little bit unpleasant to use SwiftUI, which is better than we've had in other frameworks we've seen previously. Before you write any code, we've got to add a new key to your project options. Explain to the user why you want to add Face ID. For reasons known only to Apple, we pass the Touch ID request text in code and the Face ID request text in project options. I don't know why, it's just how it is. So select up here bucket list, then choose bucket list from list of targets. And now you want to go to this info tab. Choose any existing key, like this one here, for example. Then right click on it and select add row. Inside here, you want to scroll down to the very large privacy section down here. And you see there's a bunch of different keys you can provide to unlock all kinds of things like Siri or speech recognition or TV provider or who knows what. There's lots of things inside here. And so we're going to add this one here, privacy Face ID usage description. That's the one you want to add. And I know there's stacks to choose from, but that's the one you want, Face ID usage description. Add that one now. And then for the text, enter why you want Face ID. For example, you might say, we need to unlock your data. Now head back to content view because we can go ahead and write our biometric code. First things first, we're going to bring in a new framework called local authentication. I mentioned earlier, this is only a little bit unpleasant, and here's where that unpleasantness comes in. Swift developers use a special error protocol for handling errors that occur at runtime, but Objective-C has its own special class called NSError. We need to be able to pass that into the function we're about to call and have it change inside the function rather than getting a new value back. Now, this was very, very common in Objective-C, but it's quite an alien way of working in Swift. So we're going to mark this special behavior using ampersand, change value in and let it be changed internally. So we're going to write an authenticate method inside our content view to isolate all our biometric functionality in a single place. To make that happen requires 4 distinct steps. First, make an instance of a new type called LA context, which allows us to query biometric status and perform the actual authentication check. Second, we'll ask that context, are you capable of performing biometric authentication? This is important. For example, Apple Watch or iPod Touch hasn't got Touch ID or Face ID. If biometrics are possible, we then kick off the actual request for authentication. Again, this will pass in the closure to run when it completes, but it'll read that check string we asked for when it unlock your data automatically. And when these are authenticated or not, our completion closure is called, and it'll tell us whether it's worked or not, and if not, what the error was. So we'll say down here, func authenticate. We'll make that authentication context. Our context is a new LA context like that. And the error we're going to pass in is an optional NS error. There may or may not be one. So now we're going to check whether biometric authentication is actually possible or not. We'll say, if our context can evaluate policy. So we'll say, can you evaluate device owner authentication with biometrics? And if it goes wrong, we'll pass in ampersand error. Send the error in, but the ampersand means let it be written inside that place. If we're here, it's possible we can go ahead and use this thing. We'll say our reason string is, we need to unlock your data. The same thing we added earlier on to the info tab, because it's for Touch ID now. We'll then say, our context should evaluate the policy. So it's saying here, this thing is going to say, can I actually work with this or not? So we'll evaluate the policy. And our policy is going to be, again, device owner authentication with biometrics. And then for the reason, that's our reason string. And for the reply, that's our completion closure. Are we good to use this thing or not? So we'll say, we'll receive a success or not, plus any error that took place. I've got an authentication error here. And if success is true, it means we are good to go. We have authenticated successfully. Otherwise, it means there was a problem. like that. If we get down here, we'll have an else block because it means we have no biometrics. So we haven't got Face ID or Touch ID or the Iris ID either. None of it's actually going to work at this point. Now, this method by itself won't do anything, right? It's not connected to SwiftUI at all. So to fix that, we're going to add some state that we can adjust when authentication is successful and also add an onAppear modifier to trigger authentication. And so we'll say up here, at state private var is unlocked is false by default. And this simple boolean will store whether the app is showing its protected data or not. So we'll flip it to true when authentication succeeds. And so down here, you can see we have this little comment saying success. I'll say is unlocked is true. Otherwise, the problem, just leave it as false. And finally, we can show in here the current authentication state and begin the whole process of authentication inside our body property. So we'll say we have, let's do a vstack. If it's unlocked, do text of unlocked, locked. Otherwise, text of locked. And I'll add onAppear perform, not like that, so please, really authenticate, like so. So we attach the onAppear perform to the vstack, so it's going to work on both these things at the same time. Now, if you run the app, it's probably going to say locked and nothing else, like that. This is because by default, the simulator hasn't actually opted in to biometrics, doesn't know it's available. And with no error messages, there's nothing actually happening here, just fails silently. If you want to take Face ID and similar for a test drive simulator, you want to go and choose device, IO features, there it is, Face ID, and select enrolled, like that. So now we're enrolled in Face ID. When you want to launch the app again, the onAppear perform triggers this time, and we'll say, do you want to use Face ID? Yes, we do, allow. And it's now waiting for a Face ID match. Now, obviously, it doesn't using your camera at this point. We want to actually just simulate a matching thing. And to do that, you can go back to features, choose Face ID, and now choose matching face. Now, look at the shortcut here, Option Command M, a very helpful shortcut. You can just press Option Command M to get a matching face. Unlocked appears straight away. So you can see it's working correctly now. It's matching the face, unlocks it correctly, showing the right text. Now, one warning here. When you have biometrics like this we have right now, you want to make sure you have a backup plan in place if they fail. To log in with Touch ID and similar, you want to have a backup plan like an alert saying enter your PIN number or a local password, something like that according to what works best for your app. A fallback for if biometrics fail. Apple does not provide that, but you got to build it yourself.
Так, да, все понятно. Итак,
Locked and
все
nothing else.
понятно, все понятно.
Now,
один есть момент такой, что в этом дне новое — это в MapKit, чтобы сделать аннотацию, раньше нужно было писать map annotation, а теперь просто annotation. Ну, мы об этом напишем. Так, 69-й день пройден. И дальше я немного в замешательстве, потому что, с одной стороны, 70-й день, он несложный. Да. Абсолютно сколько по времени? 10 минут. 6, 7 минут и 15 минут. С другой стороны, я сейчас немного засыпаю, и как раз сейчас хорошее время пойти часочек поспать. Как раз эфир этот получился чуть больше часа. За это время я изучил 2 дня. Это 68 и 69. Пожалуй, да, сейчас я прервусь на пару часиков и потом вернусь с продолжением. Будет еще несколько дней по SwiftUI и далее наш любимый долгожданный JavaScript. Так что подключайтесь. А если вы смотрите это в эфире или в записи, подписывайтесь на мой Twitch, на мой YouTube, ставьте лайки, пишите комментарии. Это поможет в продвижении моих каналов, моих ресурсов и в целом формированию какого-то более-менее сообщества вокруг всего этого. Вам спасибо за присутствие, за просмотры, за общение. Увидимся с вами очень скоро, в следующий раз.